12.7, using congruent triangles. Example 1. To find the distance across the river from point N to point P. So you're trying to get across the river, and you're going from N to P. First, place a stake at K on the near side so that NK is perpendicular to NP. So we're going to put a stake right here in the ground so that these guys are perpendicular. So they're hitting at a 90-degree angle. Then find M, the midpoint of NK. So M is a midpoint of NK, and a midpoint means it hits in the middle. So now we know that this guy is congruent to this guy. Finally, locate point L so that NK is perpendicular to KL, and L, P, and M are collinear. So now they're telling us to go out here and find L so that these guys are perpendicular. And then when they say collinear, they're saying that this point, and this point all lie on the same line. Okay, that's what collinear means, is they're on same line. Explain how this plan allows you to find the distance across the river. So here's how we could potentially do this. If I'm looking at these triangles, I already know that the 90-degree angle right here is congruent to the 90-degree angle right here. I also know that this side is congruent to this side, and then I can conclude, because these points are collinear, that this angle is congruent to this angle because they're vertical. So, triangles congruent by angle, side, angle. So now I know that this triangle is the same size as this triangle because I have an angle, a side, and an angle. Once I know that the triangles are congruent, then I know that all the angles and all the sides are congruent, which means that on land, okay, so on land, I can measure using a measuring tape or whatever I have, the distance between L and K. I don't have to get a boat. I don't have to get anything funny. I'm just on land. Just measure it using a measuring tape or whatever you have. And then that is going to be congruent, because I have congruent triangles, to the distance across the river, which would be NP. So you don't have to like get into the water or do anything funny or send anybody across the river to actually do it. You can just measure the distance on land. Part B, does it matter how far from point N you place a stake K? Explain. So here's N. They're wondering, does it matter how far you put K? Like, what if I were to put K the whole way down here? Okay, so let me erase a little bit so this isn't as confusing. So let's say I put K the whole way down here, and I made this go like this. Would it matter? So the next thing they said was, well, we have to find the midpoint. So let's say the midpoint's maybe here. And then we have to go find this point out here, L, which is perpendicular. And I have to make sure that all of these are collinear. Would it matter that I put K way down here? Or could I still potentially do this? And the answer is no. It doesn't matter. And the reason it doesn't matter is because you're finding the midpoint and you're making sure that the angles are perpendicular. So as long as you find the midpoint here at M, then you're guaranteed that this is going to be congruent to this. And as long as you construct this guy, which is 90 to this guy, you're still going to be working with an angle side angle congruence theorem, no matter how far down you put K. So it doesn't matter.